get it started. So slope, y-intercept, slope m, y-intercept is b, and we have to know that slope-intercept form is y equals mx plus b. So start off with vocab. Let's go from there. So we have the m, we have the b. This is the easiest possible question, where you just have to really just plug it into slope-intercept form. And it'll get more difficult, like on number 3, where they don't give you y-intercept. You have to figure it out. That's the beginning. Number 2, find the slope here. What's the slope here? And so a couple things you can do. Rise over run. Up how much? What's the rise? 10. And what's the run? 1. So up 10, right 1. Slope is just 10. And what is the y-intercept? 30. Right here, 30. There's your b. So our equation. And that's 30. Right? And those right here, the rise is 10. It's 1 square, but each square is 10. Whether it's $10 or 10 miles per hour or whatever, 10 miles. So continue on, find the slope. Now, a couple ways of looking at this. The same directions as above, right? We already know slope is 3. We have to figure out the y-intercept. There's 2 ways of doing this. First is just say, well, this is x and this is y. Plug it in. We have 0. That's 3. That's 1. Simplify. And negative 3, 4, 5, 1. Don't stop here. A few people did do this. They say, oh yeah, I got b equals negative 3. And that's good, but going back to the directions, it says write the equation of the line. B equals negative 3 is not the equation of the line, it's part of it. So go back to your y equals mx plus b. Y equals m, we know is 3 because that's from the very beginning. And now we have b. Now you have an equation of lines. Now you're done. Do that. For the fraction, it's not going to change anything. So, you know, this is x, this is y. Plug it in. Equals 1/7 times 4 is 4/7. Drop 4/7 on both sides. B equals 1 minus 4/7, so it's 3/7. Now, are we finished? No. Yeah, so now we can say, we know the slope, 1/7, and we know the y-intercept is 3/7. And this was the reason we needed this algebraic method, because if we tried to graph this, we couldn't look at a graph and say, oh yeah, that goes across the y-axis at 3/7. So we did two of the easier ones. One, just plug it in right away. One, you had to look at the graph. Two, that you just had a point and a slope. One without a fraction, one with a fraction. Now let's look at two that don't give you either. They don't give you the slope nor the y-intercept. You have to find both. So two-step process. Not given the slope, calculate the slope. And then we'll go through and do what we did in numbers 3 and 4. Well, it's just like the ones above, but we have to calculate the slope ourselves. So rise, up and down, 0, 1. 3 equals 1. And equals 2. And we can use either one of these. I'm going to use this one because it has a 0 in it, x and y. So I have 0 equals 3 from here, m, and x is 1. 1. It's very similar to the one we did earlier. Both sides, add it up. So y equals 3x minus 1. One of the things about finding the equation of line is realizing what you have, what you don't have, and what are you trying to achieve. If we know we're trying to end up with this, well, I need two things: slope, y-intercept. I'm not given either, but we know how to find the slope. We know how to find the y-intercept. 3, 5, 0, negative. Negative 2. 3. Moving on it. Which point would you rather use? Probably the one with a 0. What would you use? Alright. So we have 3 equals negative 2 times 0, which means 3 equals 3. Y equals. We have 2/3 x. Yes. Now, another way of looking at this right away, if you're clever, you probably spot this and know, well, what is 0, negative 3? What's special about that? Yeah, that is the y-intercept, right? 0, negative 3. That's right there. Usually we have like b equals 3, but they just gave it to us as a coordinate. So if you recognize that this is a y-intercept, you wouldn't have to do any of this work. You just have to find the slope, negative 2/3, and then say, oh, it's plus 3. That's 0, 3. So either way. Okay. Let's take a look at. Consider line y equals x minus 5. What would the equation of line be if we're translated, moved down 1 unit, and made half as steep? So translated, what would happen in this equation if we moved it down 1? Let's do that first. equals 2. And the translation affects only the y-intercept. So -5 move down 1 would be -6. But we also have to make it half as steep. We're talking about the steepness, we're talking about the slope. So let's make the slope half as steep. 1/2 then. So think of the translation as moving the y here, affecting here, right? -5 to -6. And think of the steepness as affecting slope. Number 8. So y equals 2x. Translate the line 4 up. Okay, so moving this 4 up, we just add 4 to it. And have the same steepness, but it went down to the left or right. So instead of going y equals 2x up to over 1, they want to go down. So they basically want to go down to right 1. Step 4, and the last one, same steepness, because this is 2 up, this is 2 down, and just when you're going down, it's a negative slope, positive when you're going up. A lot of vocabulary. And on, okay, good. Which of the following equations describe line y-intercept with positive 5 or 0, 5? Just like we did before, this is the same now as which ones? Like a b value of 5. And again, reading the directions. Don't just go like this and say, yeah, you see that one's 5, so I'm done. Like, yeah, that's one of them, but which other ones have a y-intercept of 5? So a couple ways of doing this. I recommend writing them in slope-intercept form and just seeing, is there a positive 5 over here? It has to be positive. So, for instance, here, write this in slope-intercept form, y equals 5. That means 0x plus 5. So that, well, that also has a y-intercept of 5. And what's the y-intercept here? There is no y-intercept, it's just 0, so that's not going to be y. And over here, that's a vertical line. It doesn't have a y-intercept. And over here, we can subtract 5x on both sides, divide both sides by 2, and see what comes out to be. 1, 2, 5. -5x. Okay. Divide everything by 2. And sure enough, -5 over 2. Plus 5. Yeah. That has a slope, a y-intercept of 5. And lastly, subtract 2x here in the slope-intercept form. Y equals -2x plus 5. Yeah. Y-intercept of 5. You realize here, just by seeing this, if you don't read the directions, even though they're bolded and underlined, and you only circle one, you're missing out on a lot of things. Okay, 10. So find the slope 2 different ways. Many of you say, well, I know this method. Okay, that's good. Some people drew a graph. That's good too. And you just count the rise and run. But just any way that you can indicate the answer would be probably correct. So negative 2 over what? 8. Negative 1/4. By the way, this is not an optional step. I see a lot of negative 2 over 8 on pieces of paper. Must reduce it. Not an option. Something we were taught in elementary school. In a fraction, reduce it. In direction, you have to be reminded. Okay. Others said, well, I remember a homework that we found it another way. And what is that other way? Well, the slope from here to here is the same as the slope from here to here. So if I just switch it up, actually what we did in the homework, you get 2 over negative 8, which also equals negative 1/4. And if you just went ahead and plotted it, say, well, 3, 4 is right here, negative 5, 6 is right here, and you could probably do this and say it's down 2 and then right 8, so that's same thing we get here, and then of course reduce it. Go ahead and graph. Remember with graphing, if it's in slope intercept, just start at the right hand side. Start at 5. Will this graph go up or down? Down. Goes negative. Down 5, right 2. And go up 5, left 2. Make sure you draw it all the way through the entire graph. Then, this one's not solved. Go ahead and solve it. Subtract x on both sides. We have negative 2 equals negative x plus 6. And divide both sides by negative 2. Y equals positive 1/2, negative 1 over negative 2, positive 1 over 2. Negative 6 over negative 2. Oh, sorry, positive 6 over negative 2. Negative 3. So this line is going to be going up because positive, but starting at negative 6. 1, 2. Arrows on either side. So just be careful on the double negatives. Okay, y equals 7. Is that, what kind of line is that? And what's the slope? So this is the same as y equals 0x plus 7. Okay. So good idea to know that just by looking at this, it's horizontal. Another thing you can do is, like, if the x equals and y equals confuses you, just think about the coordinates. Every coordinate here is common 7. So y equals 7 for every single coordinate. So if you had an x equals 7, it'd be 7 comma something. That's why it's y equals 7. All these are something comma 7. And y is 7. And remember, if you're given the coordinates and you have to come up with it, if the coordinate ever repeats, you know that's the equation. So if the y is repeating, the y's are both 7 in the coordinates, you know the equation is y equals 7. Just a little more practice, it's the same. But if there's no number there, we have to know what's the implied slope here. So negative is the same as negative 1. Negative 1 is the same as negative 1 over 1. now we can graph. Start at +1, but down 1, right 1. We'll get the rest of it. And of course, use a straight edge. Yep. Graph y equals -2x using domain. Domain are the x's, so the vocab, you have to know that, and a table of values. So it tells you exactly what to do. Make sure you follow the directions exactly. It says to make a table of values. It tells you the x's are -3, 0, +3. Make sure you use that. Plug in -3 for x. What is -3 times -3? And then 0 times -2, and 3 times negative. So -3, 6. And this is what the poster looked like yesterday. You just saw 3 dots. And 3 negatives, right? And then use a straight edge and connect those. Yeah. Very important to follow the directions. And so what if you had the right graph, but not the table of values, and you didn't use the domain? Well, you haven't answered the question. Make sure you use that. Okay. Graph using intercepts. All right. So find the x-intercept. That's when y equals 0. Find the x-intercept. Y-intercept doesn't matter. So just find when each of them is 0. We've done this many times. Okay. So we have 4x. Now if I plug in 0 for y, it's going to be 8 times 0, which is 0, and -0 is going to be 0. So in a sense, the part that you plug in for 0 is going to cancel out. You know, x equals 4. So this, which one is this? Is this the y-intercept or the x-intercept? If you plot it, where's 4, 0? On the x-axis, that's the x-intercept. And likewise, for the y-intercept, plug in 0 for x. So that's right here. So we're left with -8y equals 2, which is the same as what coordinate? X is 0, and then y equals -2. So we know there's the other one. And based upon that, draw a line through it for your graph. So many different methods. We did slope-intercept. We did use a table with the domain. We did graph by using intercepts. Now we have all those methods. All right. Last page. Let f of x equal 1/3 x. And find f of 9, which means, kind of like the domain problem, plug in 9 into here, which you get. So, proper way of writing this out would be plugging in 9. So, what is 1/3 times 9? it's kind of actually the same exact thing we did in the domain question, asked a different way. Over here just means, hey, I'm plugging in 9, and then on the right-hand side means, well, I plugged in 9 and I got my answer. So at the end, you can see I plugged in 9 and I got an answer of 3. This is the X, this is the Y. This is your graph. And 18 is just another practice. So let's plug in -4 into here, and let's see what we get. -4, do some order of operations. -4 times 2, -8. And -8 minus 1, 9. So that means we plugged in -4, we got an answer of -9. And we could say, you don't have to write this down, but it means that -4, -9 is on the line. So this is why we use this format. You can see what we plugged in, that's the X. What we got as our answer, that's the Y. Now we know that's the point on the line. But really all you need to do is have 19, is this a function? I mean, is this relation a function? Why or why not? Alright, so recall that with functions, you don't care about any of the lines, right? What are you looking for in the x's? Okay, anything repeat?
No.
So what's the answer? Yes or no? Is it a function? Yes, it is. Be careful with the language. No, nothing repeats, therefore, yes, it is a function. You say, then, is this a good enough answer? No. No. What does it say right here? Explain. That's not optional. If you don't explain, yeah, you haven't answered the question. So, yes, and you just explain your logic. Repeat. Write the word which you use to come up with that answer. Let's see, let's do a little bit of solving now, and let's get started on these. Review. Solve x, 7. So remember, you want to cancel out all the variables on the right and the numbers on the left. And in this case, the variables on the left be canceled out as well. If you cancel out everything on one side, what does that equal? Yeah, it's 7 minus 7 is 0. At 0, 6 minus 7, 1. Alright, conclusion. Does 0 equal -1? No. Therefore, the answer is conclusion. And whenever the equation or inequality is false, it's no solution. Same idea, add 3x to both sides, and subtract 5 on both sides. So obviously we're giving you these problems on purpose so you have practice with these special cases. So again, everything cancels on the left. Compare them. -2, -5 makes -7. Right, is this true or false? True. 0 is bigger than -7, therefore all real. So yeah, unfortunately, you can do all the algebra, but then mess up the interpretation if you don't know that 0 is bigger than -7. Be careful. Anytime you have a true answer, you're going to have all this. 1 is 2 is 3. So we have negative 1/4 times 4, negative 1. And 1/4 of 8. Solve. 2x equals 11. Not that many. X equals negative 11. Please leave your answer as a reduced fraction. Don't make this 5.5 or 5.5 or anything. This is fine the way it is. It just should come directly from solving the equation. If it was 22 over 4, then reduce it. Like, keep that improper, more proper fraction. Last few. Perimeter of a rectangle, 20 feet. The length is 2 feet shorter than the width, as you can see here. So the width minus 2 is the length. Oh, there's one more. There it is, 20 feet per 180 inches per minute, 2 inches per second. So we're only changing the time here from minutes to seconds. Inches are going to stay the same. So 180 inches. This is like a slope, right? 180 inches for every 1. You gotta graph it, it'd be up 180, right 1. We want to make this into seconds. So I'm going to cancel out my minutes. These minutes are on the top, or the bottom here. I'll put it on the top here. Go below it. Now my minutes will cancel out. I'll be left with inches on top, seconds on the bottom, which is the same as inches per second. Then plug in the values. How many seconds in a minute? No. So we have 180 over 60, which is inches on top, seconds on the bottom. 3 inches per second. So if you're going 180 inches per minute, that means every second you're going 3 inches. And when you go 3 inches 60 times for each second, you end up 180. Now down to the perimeter. Right? So we have to know, I think it's from 2nd or 3rd grade, that if this side is the width, this side is also the same. This side is the width minus 2, this side is also the width minus 2. So as we walk around, we're going to have the width minus 2 plus the width plus the width minus 2 plus the width. Add them all up. So to find a variable, we gave you the variable. So you just have to write down W stands for the width. Okay. Write an equation, say it out loud, so it's write it out. So we have W minus 2, the top side, the right side, bottom side, and the left side. Should have 4 of them because there's 4 sides on the rectangle, right? And we know that this is going to add up to what? 20, okay? Now, W, 2W, 3W, 4W. Minus 2, minus 4. And solve. Add 4 to both sides. Divide both sides by 4. length is 6. W is 6. 6 what? Feet. Get those units in there. The only thing different from the equation to this, part 4, add the units in. What is the length? 4 feet. 4 feet because it's W minus 2. Verify this actually works. So my width is 6. My length is 4. Does this add up to our perimeter?
Yes.
Yeah, so please make sure, verify whatever answer you get actually adds up to the perimeter that you are given. We've had some weird answers where we get like the width is 78 and the length is 84, and it says above the perimeter should be 30. Well, if it doesn't add up, something's up. There's perimeter. And instead of proportion and salt, for our last problem, heights and shadows, which are proportional. We have a 5-foot tall person with a 3-foot shadow, and we need to figure out how tall this person is that has a 4-foot shadow. So we can set it up 4 different correct ways. We can do the first person's height and shadow could be proportional or equal to the second person's height shadow. We can say the heights on the first one, and then the shadows on the second one. We can say we can flip it around and say, well, I want the shadows on top, the heights on the bottom. But there are a lot of different correct ways of getting the same thing. How do you know these are all going to be correct? Is that when you solve them? Right? You can see they both come out to the same thing. So we're going to get 20 equals no matter which one I use. You don't have to do both. But that's how you know that they're correct. Because they both give you the same exact equation. When you do the cross multiply. Divide both by 3. So how tall is this person? Would you say, if somebody asked you how tall you are, would you say I'm 20 over 3?
No.
No. So this is a situation that's opposite of what we just did over here. If it's just a regular equation, leave it as an improper fraction. If it's a word problem, you need to make it have, you need to make it sense. Make sense out of it. So we don't talk like this. We don't say it's 20 over 3. So convert this to a mixed number or a decimal. So this would be what? 6 2/3. What are the units? Feet. Now, have you ever told somebody that you're 6 2/3 feet tall? Well, even that's a little weird, right? So how much is 2/3 of a foot? How many inches is that? 8. So 6 feet, 8 inches. Or you can just write out 6 feet, 8 inches. And this is how we really speak. So just ask yourself on your answer of a word problem, would you ever say I'm 20 over 3? No. Would you ever say I'm 6 2/3? No. Would you say that I'm 6.66 repeating feet tall? No. So have it make sense.